Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Tranquility and Serenity. So what do we see here? Well, here we see an image of our moon, or at least a small portion of our moon. And we're looking at two of the Maria. Maria on the moon are known as seas. Now, these are not seas in the way we think of here on Earth. They are flat lava plains where material has flooded into old impact basins. And this occurred long ago. In fact, everything on the moon pretty much occurred long ago. The lighter colored areas around the highlands are 4 to 4.5 billion years old, dating back to the earliest history of our solar system. The Maria are younger. But while younger, not a lot younger. They're about 3 to 3.5 billion years old. And really, the moon hasn't changed a whole lot in the last 3 billion years. It looks about the same. Yeah, there's been a few new craters that have occurred, and impacts do slowly occur, but not a lot of them. And in fact, the overall structure of the moon and the general features that we see would be the same if you went back 1 billion or 2 billion years in time and looked up at the moon. It would look very familiar to you. We'd be seeing the same type of thing. Now, the seas here, these are the Sea of Tranquility to the right and the Sea of Serenity to the left. And those are two of the Maria on the near side of the moon. And in fact, almost all of the Maria or flooded areas like this are on the near side of the moon. When we look at the far side, it's very much all highlands, all the lighter, heavily cratered areas. And we can use that cratering to judge the ages of objects here. So when we look at the Maria, we can see that there's far fewer craters there. When we look at the lighter regions, we have craters on top of craters on top of craters. They've been pounded by a lot of material from space over that first billion years when things were really being impacted. So we can see all that. So the crater counts are one way we're able to tell ages of things in the solar system or on the moon, is this one. So the more craters you have in a certain area, the older it is, the longer that surface has been exposed to space. Now, there are more accurate ways to be able to measure, but that requires actually getting a sample of the material to study in the laboratory and using the decay of radioactive elements to be able to look at this and study how that has decayed. That allows us to determine the age of it much more accurately. But you need a sample to do that. So while it does work for the moon, we do have samples of the moon, including of the Sea of Tranquility, where the Apollo 11 mission landed back in July of 1969. But other areas on the moon we don't have samples of. Other planets we don't have samples of, or other moons. We don't have those samples to study to really be able to tell what things are in terms of age. So crater counts are one thing that we can use to compare ages across objects throughout the solar system. So that was our picture of the day, titled Tranquility and Serenity. We'll be back again tomorrow for the next picture, previewed to be a galaxy cluster forms. So we'll see what that is about tomorrow. And until then, have a great day, everyone. And I will see you in class.